Welcome to this panel discussion on new opportunities for innovations in energy and climate technology. I'm David Lodge. I'm a professor in the Department of Ecology and Evolutionary Biology at Cornell and the Francis J. DeSalvo Director of the Cornell Atkinson Center for Sustainability. Cornell Atkinson is the hub of collaborative sustainability research at Cornell, and we forge vital connections among researchers, students, staff, and external partners. Because the center's funding and programming accelerate groundbreaking research across all of Cornell's colleges, schools, and departments, it's only natural that I have the privilege to moderate this cross-college panel. And with over 600 faculty fellows across the university, Cornell Atkinson provides a wide range of opportunities to connect researchers and, in collaboration with external partner organizations, take knowledge to impact. The plan to build Atkinson Hall at Cornell, recently announced, will make it even more possible to bring faculty and partner organizations together and manifest Cornell's commitment to helping solve sustainability challenges. The topic of today's panel addresses two of Cornell Atkinson's four priority topics: accelerating energy transitions and reducing climate risks. Across all of our priorities, we also seek solutions that simultaneously advance social equity and justice. It's a privilege that we've brought 5 experts together for this panel discussion today, and I'm going to introduce all 5 of them right now before I start asking anyone any questions. I'll start with Dean Lynden Archer, who was appointed Joseph Silbert Dean of Engineering in July 2020. A Cornell faculty member since 2000, Archer directed the Robert Frederick Smith School of Chemical and Biochemical Engineering from 2010 to 2016. Archer is a fellow of the American Physical Society and a member of the National Academy of Engineering. His research has led to the creation of a technology company, Gnomes Technologies, that is commercializing electrolytes for safe lithium batteries. Next, I'll introduce Dean Ben Houlton. It's really exciting to welcome our new Dean of the College of Agriculture and Life Sciences, who arrived at Cornell on October 1st. He came to Cornell from UC Davis, where he was the director of the John Muir Institute of Environment and a professor of global environmental studies. Ben is an accomplished environmental scientist, recognized internationally for research collaborations in ecosystem processes, climate change solutions, and sustainable agriculture to promote planetary health and resilience. Next, Professor Natalie Mahowald is the Irving Porter Church Professor of Engineering at Cornell University, as well as the co-lead of Cornell Atkinson's Reducing Climate Risk Working Group. Her research focuses on modeling natural feedbacks in the Earth system, especially associated with aerosols and biochemistry. Natalie was a lead author on the 2018 United Nations IPCC Special Report on the impacts of 1.5 degrees Celsius global warming. Professor Lindsay Anderson is an associate professor in biological and environmental engineering, the Kathy Dwyer Marble and Curt Marble faculty director at Cornell Atkinson Center, and the interim director of the Cornell Energy Systems Institute in the College of Engineering. Lindsay's research interests center on the effective integration of renewable and distributed resources in energy systems. Finally, Armando Oliveira is the retired CEO of Florida Power and Light and a Cornell alum. Florida Power and Light was one of the largest investor-owned electrical utilities in the United States. In 2017, Armando joined Ridge Lane LP, where he is a venture partner in the sustainability practice. Among Armando's many volunteer roles for Cornell, he is a former university trustee and a current member of the Cornell Atkinson Advisory Council. So I'm going to start the questions with one for Natalie. Sort of to set the stage for us, Natalie, you've been engaged in many reports, including, I mentioned, one of the IPCC reports that take a global perspective on climate change. What does the transition to the Biden administration and, for example, the US re-entering the Paris Agreement mean for the global picture on climate? And from your research and engagement on the IPCC, what does that accomplish for the US and the world, and what still remains to be done?
Well, I'm really happy to try to answer that question. And I'm really going to take the global perspective on that and think about that from the IPCC, from the Intergovernmental Panel on Climate Change and the UN's perspective. If you take a look at the numbers, if we want to reach low climate targets, which is really anything below 3 degrees C above pre-industrial, it's really going to take a tremendous transition of our economies. It's an unprecedented change compared to the past. Now, obviously, we need a transition in the power sector. We have these amazing technologies, wind and solar, which are cheap and renewable, supply renewable energy. So this is great. We have the technologies, and the most important thing is to transition our power sector away from fossil fuels to renewable energies. But in some sense, this is the easy part of the problem that we can solve now. We also need to reduce energy demand as well. We're going to be electrifying other parts of our sector to put them onto the electric grid. Well, that's going to put more demand onto our power grid as we try to transition to renewables. So that's going to make things harder. We need to reduce energy demand in order to try to reach the goal of getting our power sector 100% renewable. Now, we also have to realize that some industries, it's difficult to impossible to electrify. So 15 to 40% of our CO2 doesn't have a technology that can get rid of that CO2 emission. So we need to develop new technologies and implement them. We also have to realize that developing countries are developing right now, and hopefully they won't emit as much CO2 as we did when we were developing, but they're already going to be emitting CO2. So because of the difficulties of transitioning quickly, we're really going to need to develop some technologies to remove carbon dioxide from the atmosphere. These are called either carbon dioxide removal or negative emissions technologies. And these need to be scaled up to a huge level in order to address the problem. Right now, there's a lot of options on the table. None of them are perfect. None of them are cheap, won't cause environmental damage, easily available and scalable. But there's a lot of ideas out there. So we need to hone those ideas and figure out which are the best ones. Solving climate change, trying to reach these low climate targets, this isn't going to be easy, but the U.S. is really traditionally right on the edge of science and innovation, and the edge of innovation in technology, and the edge of implementing from a business perspective all of these ideas. So we can't underestimate the role that the US has to play in leading this effort. And concentrating on the climate question really plays to the US's strength in terms of innovation in all these different sectors. Thank you.
Thank you, Natalie. So, yeah, Armando, Natalie talked about sort of technologies and the need and the urgency behind new technologies. Given your role previously as a CEO of a major power company and now serving as a board member on another leading power company, you have a unique perspective on an industry that's both dependent on technologies and governed by policy. I recently read an interview by of the CEO of the Southern Company who put it this way: you tell me what the policy choices are, and I'll tell you what technologies are in the money. So how do you see this intersection between technology and policy? What are the opportunities to drive the innovation that Natalie talked about toward a more resilient future within the power industry?
So with all due respect to my friend Tom Fanning at Southern, I would disagree with that comment. I think, when you look at the technologies, and Natalie touched on this in a very articulate way, we still have a long ways to go before we have a fully renewable power system anywhere in our planet. And so that's going to require a lot of innovation. And so to say, tell me the policy and I'll tell you whether it's cost effective or not, frankly, it is an outdated thought. And if you go back at history, I can tell you from personal experience that when we built the first wind turbines out on the outskirts of San Francisco, and the people called them egg beaters, people thought we were nuts. And had you looked at it in that context, through that prism of saying that, you tell me the policy, we would have never become the #1 player in wind energy in the country and arguably in the world. So I think, and so let me also make another point, tag on to Natalie. I completely agree with her on energy efficiency. If you look at the most, and I believe it's still true today, the most cost-effective way to reduce carbon is through energy efficiency. And it is something that is largely driven by policy, because how utilities get paid, there are incentives to reduce sales and reduce consumption, but frankly, they're not anywhere near where they need to be. So we have to, from a policy point of view, that should be the #1 priority going forward, is how can we make that happen? And then we can talk later. I mean, I have obviously some more thoughts on the policy side, but the regulatory schemes in this country have been mostly aimed at keeping the bills the lowest possible in a very short time horizon, as opposed to really saying, look, we have a major threat to this planet, and we're not moving anywhere near fast enough to make those changes, and certainly not in the power system, which is really the foundation for, whether you're going to heat your home and transportation and so many other things. So I will stop there. I can go on and talk about policy for a long time, but I think you understand where I'm coming from.
Yeah, Armando, I think we'll have time. I hope we'll have time to come back to some policy discussion. But let me just ask one quick clarifying question. So your example of the early wind turbine that you put up, you're saying there's a role for power companies to invest in some new technologies, even apart from the policy driving it to begin with.
Absolutely, there's a role, but there's a role more in implementation. Utilities are not good innovators. And so we have to look to the entrepreneurs. And I've been fortunate enough in this last phase of my career to work with entrepreneurs. And that is really where you're going to see the breakthrough technologies, which utilities can readily adapt and implement in their systems. But I think it's virtually impossible to come from there, both because of the regulators, and secondly, because you are really beholden to quarterly earnings reviews. And that makes it very challenging to really do innovation, because we know that intrinsically in innovation, there's going to be failure, and you're not going to be rewarded for that.
Great, thanks. Well, let me turn to our two new academic leaders, our two new deans at Cornell now, for their impressions on the role of a research-oriented university like Cornell, and how the priorities in their colleges can inform and affect the kind of trends that we're talking about. So first, I'll turn to Ben. You've hit the ground running at Cornell, quickly helping to coalesce expertise around climate and bringing new ambition for what Cornell can do. We've all seen and appreciated that. Now, your past work explored global carbon sinks, and you now have experience in both California and now New York, which in terms of state policy are two states leading in reducing climate risks and ambition around decarbonization, including in agriculture. So as a leader now working at the intersection of agriculture, the environment, and climate change, within a leading land-grant university, what have you seen in terms of how policy and research can interface productively?
Thank you for that question, David. Yeah, well, first of all, I want to say I'm coming into a situation at Cornell where we already have a deep bench and a full cover. Thanks so much to Cornell, Atkinson, and my colleagues here. There's nothing like coming into an environment that is shovel ready to unleash innovations in climate. So, coming from California, realizing that there's so much to learn out here in New York State, it's been a great transition for me. I want to echo, Natalie and Armando are hitting all the right notes from my perspective, thinking about the global picture and the challenge, which Natalie painted vividly for us. It's a massive undertaking. And through the lens of the power sector, and what it really means when you're a CEO and what you're trying to accomplish. So a lot of controversy. I like to say there's not really controversy over the changes that we're seeing. There's a huge amount of debate over the solutions and how to deploy them effectively. And I think that's why we're having this conversation today. So I will just shift focus quickly to agriculture. Given that I'm the Dean of Cals, we think that agriculture can be a powerful weapon in the fight against climate change. There's no doubt agriculture has contributed to the challenge, but now is the time for agriculture to innovate and create solutions. And then when you think about 10 billion people, 2050, that's the projection. We're going to have many mouths to feed. We're going to have to do it while reducing our footprint on the land and helping to think about biodiversity. And we're going to have to reverse greenhouse gas emissions and create sustainable sinks. So it's Herculean, but that's what the research, that's what Cornell was created to help solve, these kinds of challenges. So a couple of points, one, many of our listeners here, I'm sure, are familiar with the gig economy, all too familiar, but we need a gigaton economy. That's where carbon is the commodity, and we're talking billions of tons of carbon dioxide removal and deep greenhouse gas reductions. Much of this will be low-tech solutions. We're not talking about things that are, super difficult to accomplish, and agriculture has a global infrastructure in place to make these things go. But carbon pricing is a major accelerant. We need carbon pricing from a policy perspective. Where does R&D come in? Well, a couple of just very general ideas. We need to verify the carbon drawdown benefits. A lot of the carbon goes into the soil or into plants. It's spread throughout the planet. We want that to happen. How do you measure and monitor that? Well, we're going to need AI, drones, sensors, blockchain. I mean, this is where I think Silicon Valley meets this problem, because we're going to need to be able to rapidly assess carbon benefits in order to support a new carbon economy. So this work's already happening. It is definitely an area to watch, and Cornell is really in a great position to continue to lead the charge on these innovations.
Great, thank you, Ben. And Lynden, from the perspective of a new dean of the College of Engineering, how do you see engineering solutions, emergent technologies, and the intersection of disciplines in understanding and helping to solve the problems of energy creation, energy storage, and mitigating impacts of energy use?
Hey, David, thanks for that question, and to the listeners, thanks for having me as part of this discussion. So look, I believe that engineers have over the last 75 years or so proven what the power of innovation can accomplish in terms of moving society in directions that were not at all anticipated even 75, 100 years ago. And the climate problem is one where I think it's ripe for this type of innovation, as you've heard from Natalie, from Ben, that these problems are hard and they require solutions that scale. And I think they're compounded by the fact that the changes we seek must come very quickly, right? And at a very large scale, a planetary scale. And these are domains where I believe engineering and engineers have historically excelled and have room, I think, to contribute. Now, in fact, if you look back at how we got here, right? A looming climate catastrophe in less than 200 years since the dawn of the second industrial revolution. it underscores, I believe, the importance, perhaps even the moral responsibility of engineering and engineers for reversing the systems we built that got us here. I think Cornell Engineering is a unique place to have this kind of perspective because we have a number of what I call unfair advantages. And the first of which is that we have a deep bench of expertise in basic research, which you've already heard about. We also have in the College of Engineering a mission to translate our most innovative research ideas from the lab to applications that impact people and ultimately that can change the world. So we're well positioned to address this problem. And I would argue that Cornell itself has actually been a beacon of hope in the willingness of the university to use the campus as a living laboratory for pilot scale tests. Obviously, this started with the Lake Source Cooling Project that's now a runaway success, and it's poised to repeat itself with the Earth Source Heating Project that I'm going to talk about later. But David, you specifically asked me about intersection between disciplinary domains. And so let me spend a minute giving you a sense of the example that I see going on in our college. It gives me confidence that when we bring together people from across disciplinary silos, there's an opportunity to have real and perhaps even transformational impacts. So the first example I want to give, it's a quick one, of a company called Dimensional Energy. This is a Cornell Engineering startup that many of you might recognize as the recent announcement of Carbon X as a finalist in the Carbon X Prize. Now, this company was founded by research, independent research actually, from my colleagues Tobias Hanrath in chemical engineering and David Erickson in mechanical and aerospace engineering, where together they discovered a photocatalyst chemistry that can use sunlight to convert CO2 into valuable products, including jet fuel. I believe their approach addresses the most important aspect of the grand challenge, and which is in fact why I think engineering solutions are important: how to create enough value for captured CO2 to drive a vibrant circular economy based on CO2. I think if we can solve that problem, it reduces the incentive from power companies to pollute with CO2, and it drives the incentive of capture technology to create a raw material that is intrinsically valuable. Now, as a second quick example, I would like to draw your attention to the Earth Source Heat Project that many of you have probably heard about that is ongoing on campus. This project is a collaboration between a chemical engineer, Jeff Tester, and an earth and atmospheric scientist, Teresa Jordan, and others. This project was funded recently by a 7.5 million grant from the Department of Energy, and there's a real opportunity now for a much larger grant of 35 million that we're going to use to basically demonstrate this project at scale. Now, it addresses a pretty important need, the need for baseload sources of renewable heat and electric power in the New York context, where heat accounts for about 31% of the energy use every year. This provides an opportunity, I believe, for real impact and presents Cornell, as I believe, the right institution to pilot this design so that we can perfect it on campus and ultimately take it out into the world. So a great question, and I look forward to answering and providing more context as we go forward.
Great, thanks, Lynden. And Lindsay, you've been waiting patiently. Lindsay, your work often takes a systems level approach. I know you think about sort of optimizing the systems that comprise our energy grid, and you've been leading the Cornell Atkinson Accelerating Energy Transitions Working Group. We know that there's high interest, as other speakers have mentioned, in scaling renewable energy, expanding it. But I think your work would suggest that you have to do more than just add more renewable energy, add more windmills, and add more solar arrays. So what else do we have to do? What are the challenges? And if you'd like to comment on the relevance or not of the last month's winter storm in Texas as offering any instructive lessons, feel free to do that.
Okay, great. Thanks for the question, and thanks for having me here. So basically the challenge with power grids, right, and transitioning to renewables is that we need to instantaneously ensure perfect balance, right, between demand and supply at every location at all times, or we get blackouts, which we know are unpopular. And so that's a complicated problem in and of itself, right? But as we add more renewables, we increase the uncertainty, where previously we might have known exactly what we could expect from different generators in different locations. Now we're not quite sure, right? So we can say, oh, we take this complex sort of decision-making problem and we say, and actually we don't really know the values of some of the variables or some of the boundaries, right? And oh, you still have to solve it really fast. So that's really challenging. And by electrifying heating, cooling, transportation, we sort of add to the load, as Natalie pointed out. So we add to the burden to the electric system while simultaneously increasing the uncertainty. Which sort of brings us to your question, which is why can't we just add renewable capacity? And we can't do that because, first of all, it would be prohibitively expensive, even if it was technically possible with the devices and technology that we have today, right? So what we need to do is look to synergistic technologies and synergistic behaviors, right, which keeps coming up in this conversation, to make this balancing work, right? So as supply changes, we need the demand to change as well to make this balance, right? So if you think about a simple example of, if clouds cross your massive utility scale solar farm, you might not lose all the power, but you're going to see a dip in what they're producing. And we need to do something to provide that power, right? That we no longer have. So right now what we do is we just ramp up fossil fuel generators that are sitting there sort of running at a low level, or we just increase them from their operating point, mostly natural gas, right? Which then contributes to emissions. But something that we've been talking about for a long time is this idea of using the supply side, using real-time demand response. There's been a few successful demand response programs, mostly, focusing on summer peak periods, but a broader application where everybody would let their houses sort of adjust their air conditioner or their heat pumps or their electric car charging. And it would just provide a small drop. But if you have millions of homes doing this, suddenly you have massive levels of flexibility to balance the supply side uncertainty. And it could be done, in a relatively imperceptible way to the consumer. With very little cost, the technologies are there and no additional emissions, right? So this comes back to the energy efficiency and consumer part that we were talking about earlier. So we do need to add renewable capacity, but we also need to figure out this right way to get the consumers involved, right down to the end user to provide this flexibility. And it's actually probably a more challenging problem than developing new technology in the lab, right? How do we motivate people? How do we change behavior? That's really hard. And it's still open. So that's the challenge of decarbonizing the energy system. And then you mentioned the Texas problem, and I will comment on this because I want to make it really clear that last month's disaster in Texas was not a renewables issue. I'm gonna pause there for a second. In fact, the solar resources were there. There just wasn't enough solar to make a difference. So if we'd had solar and some storage, that would have been a total game changer. The main issue was a problem with preparedness for these extremes and a lack of interconnection to other regions, right? Because Texas is fairly isolated. So obviously forecasting extreme events is going to be really important, and anticipating that impact. So in this case, the wind farms were frozen and the natural gas wasn't flowing and it was in short supply. But again, I could tie this back to the consumer behavior question, right? Because it highlights the potential of the demand side. What if people had somehow been able to behave quite differently, right? Using just absolute minimum electricity at that time, the system might not have been quite so pinched, which is exactly what they were doing with the rolling blackouts, right? Isn't it? It's sort of a brute force way to reduce demand. So that I would say that the technology solution for demand response is there. Most homes, or many homes, have smart meters. They have that capability. But the hard part is getting the behavior to change, and that will help us in extreme situations as well. But we have to figure out really the proper incentives, market design, policy, the innovation, in the business sector to facilitate that real behavior change, to support transitions of the system more broadly.
David, can I add to that for just a minute?
You certainly may.
Again, to build on Lindsay's, going back to your comments about policy, I mean, part of and I agree with Lindsay, this is nothing, even though it became very political, nothing to do with the renewable resources, but it had to do with the flawed market structure. And here's when you go back to policy, right? And you can have great technology, but if we have really what I consider to be a deeply flawed policy, you end up with a lot of unintended consequences and a less reliable system.
No, thanks for that additional perspective, Armando. So we may only have time for one more round of questions. There's so many things that I'd love to pursue, but let me ask a question. I'll give Natalie the first chance to answer this question, and then I'll ask if others would like to pipe in. As the U.S. decarbonizes and adapts to climate change, do you worry about the social equity and justice impacts? I mean, when we look at the impacts of climate change, when we look at disasters that are exacerbated by climate change, it's very clear that communities that are already vulnerable suffer by far the worst. And when we talk about some of the technological innovations, when we think about the electrical vehicles on the road now, it's people with wealth and resources who are driving those. And we're talking about the need for systemic, deep and broad change. So how's that going to happen in a way that not only doesn't exacerbate the increasing wealth gaps in the U.S., but actually could reverse them? Is that possible? Natalie, that's a bunch of issues wrapped up in one. What do you say?
Well, it is what we tried to address in the 1.5 report, more on a global scale. But truly, that's the challenge, right? Is how do the poor and disenfranchised are harmed the most by climate change. But if we mitigate wrong, they will be harmed there too. But actually, things like solar and wind and putting in new infrastructure, this is actually in some ways a job creation program, or should be. If we do this right, we will reduce the inequities in the system. And that's what we need to try to do. We really need to worry about climate justice issues, they're sometimes called. But I think there's a lot of solutions and policies that would both help the climate and help those social equity system problems that we have.
Great, and it'll be great if people can keep their answers short to this. I hesitate to put anybody on the spot. Ben, I suspect you might have some thoughts about this.
Well, yeah, I mean, I totally echo what Natalie just said. You know, when we think about food systems, we are talking about meeting the needs of a growing world population. We already have 800 million people on the planet who don't have access to food. They're food insecure. They're suffering from hunger. We have another 2 billion that are estimated to suffer from micronutrient deficiencies. So when we think about agricultural innovation and the resiliency it provides in this gigaton economy, it is one that actually provides monetary benefits to these communities and does it in a way that uplifts the nutritional value of their food and provides food sovereignty. And I think all of that needs to be part of this puzzle. Otherwise, we'll create additional problems through the solutions, and we will be having a conversation in 20 years that looks even darker than it does today. So I hate to say it, but we have to be infusing these ideas into our solutions.
Would others like to chime in on this topic before I ask another question? Armando?
Yeah, I'd like to go back for a second, and because I think right now we really are seeing that poor people are not able to really make a significant contribution to reduce carbon. They can't afford to make their homes more efficient. They can't afford heating. They don't drive Teslas. I mean, you can go on and on. And I'll go back to policy because that's sort of been the theme in some throughout our conversations. And Ben touched on it. I think the single most important thing that we could do is to put a price on carbon. And we can put a price on carbon in a way that's not regressive towards poor people. We can issue those people back credit. It's a heck of a lot simpler than so many other policy things that we're talking about. And I think if you want to have kind of a sort of a progressive policy, carbon tax can get you there the fastest way. Put aside the politics, and I'm not going into that part of it.
But so Armando, it's been surprising, I think, to some of us that a carbon tax looks potentially, maybe even politically viable these days, when many of us had declared it to be dead in the last couple of years. What's going on? You've got industry groups, in fact, in the last few weeks that have endorsed putting a price on carbon.
I'll give you one man's opinion, right? We are seeing a lot of pressure from investors. And we're talking about really big funds that are saying, we are not going to be buying your stock anymore. Look at Blackstone, if you're interested, the CEO letter, and what they are saying to boards of directors, what their expectations are, which is you have to have a plan. We don't want to just see what your carbon emissions are like. We want to see a plan, and we want to see really a transition, how you're going to get there. And you know what, David? That will also make a huge impact. And I would encourage those of you who are involved in policy much more directly than I am to look at some of these. Blackstone is, it's one of the key investment funds. They own, I don't know how many trillions of in equity. And to have them come out with that is huge. And I think that is what is making carbon tax much more palatable. One man's opinion.
Yep. Fascinating. I guess I've also wondered whether one of the other driving forces is this, that maybe the clarity of a carbon tax looks more appealing than sort of command and control regulation that may be different in different political jurisdictions. Could that be the case also? Lynden, let me turn to you. Well, first of all, anybody else want to comment on the current topic?
Sure. Yeah, I do, David. So I wanted to put a slightly different twist on this, and this is driven by my own background. So I grew up not in the United States, and so I'm used to seeing things on a sort of global, through a global lens. And of course, the reality is one of the reasons we developed so quickly in the Western world and now increasingly in Asia is the cheap cost of energy. And I think as you think about equity, I think it's important to also think of justice, that there are regions all around the world where people are poor, not because they're intrinsically poor, but because they're in a different schedule for development. And correctly, I think Natalie said it, you can implement policies that are relevant and quite reasonable for the United States, but it ends up leaving more people behind and creating even more of a catastrophe because they don't get the right or the opportunity to develop as quickly. So it's a complicated problem, and one where I believe there's somewhat of a moral responsibility for those of us in countries where A, we have the ability to pay for innovation, and B, we're responsible for a lot of the CO2 in the environment, to think about this in a more global sense, because the impacts are pretty significant and global.
Yep, thank you. Lindsay, let me turn to you. I wonder if your experience in Puerto Rico and thinking about the grids and increasing resilience in areas where resources are sometimes more limited. Any thoughts about that?
Yeah, I think your question about sort of the justice of this transition is really relevant in Puerto Rico, right? Because as we saw in Puerto Rico when we had these massive blackouts, right? And people, especially in rural areas, were off grid for without power for a year. And so there was all this talk about, and there's issues obviously around regulation and policy with the system operator there that are clearly policy related, but also there's all this talk about, the people who have the resources then are going to go off the grid and they're going to get solar panels and they're going to buy batteries, right? And you can see how this transition would go if people who could afford that, they remove themselves from the grid, then the people who remain who could not afford those resources are going to bear the burden of maintaining that infrastructure, right? Because they have to pay to maintain that. So by the people who have the resources moving off grid, it actually increases the burden on the people who are unable to do so. So it exacerbates the inequities for sure in the socioeconomic situation there. So that's a challenge that really needs to be addressed.
And I think maybe it partly illustrates a global challenge, which is the the places where technological innovation, which many of your comments have emphasized today, all of you, the place where that happens is in the United States and other richer countries, and yet the problem that brings us together this afternoon is a global problem, and the technologies and other approaches are going to have to be applied globally. So, Natalie, do you have thoughts about how do we solve that problem? Technology invention in one place, solutions derived in one place, but really unavailable under many circumstances in other places. What do we do?
I think this is where Cornell has an obligation, and the U.S. has an obligation to really provide innovation, do the R&D, do the deployment, debug the problem, and then make sure that the technologies and the policies and the whole way, the procedures are available to people in other countries. We don't want to force people to do things, but rather make available to them the technologies that could help. And that's what needs to happen. In the future, it's going to be the developing countries who would emit the most CO2. That's where most of the people are, okay? So they're the ones who have to make the decisions to cut the CO2 emissions as we move forward. Not just us in the risk countries, but the developing countries. So I think that's where our obligation is from a university perspective, is really supply the knowledge and make it available. And I think that's perfect for a university like Cornell.
Perhaps we should end on that note, but we're not going to. I'm going to give you a chance for a lightning round here. So answer's got to be less than a minute. But final parting thoughts. What's the most important thing that needs to be done that we haven't touched on? Who wants to start? Armando does, I think.
Oh, gee, you caught me thinking as I think that we've talked about the global issues. I think in tandem, we also should consider what I call lots of short-term solutions. And by that, I mean, and this is from somebody who had to be an implementer, right? My whole career was how do we make things? What do we need to build? And I think we could, and I'll give you some examples, right? You cut
probably only time for one.
Okay, cut red tape in building offshore wind.
Great. Okay. Yep. The short-term solutions, as Armando said, got to be short answers too. Who wants to go next?
So I can do a quick answer. I've given this example before, but I think fundamentally we have to figure out how to convert CO2 into a useful product. I'm inspired by the late Buckminster Fuller, who said waste is only waste because we don't know what to do with it. And I think if we can figure out the technology that allows us to use CO2 to add value, my goodness, I mean, we wouldn't waste it anymore.
Great. Ben?
I'll do, oh, sorry.
Oh,
Go ahead, Lindsay.
go ahead, Lindsay.
I'll be 5 to 10 seconds. And I'm going to take the flip side because I'm a technophile, right? I love the technology. But I think, in making a fair transition, let's make sure that we have more people at the table, right? So having a diverse set of stakeholders making the decisions and making the plans and generating new ideas, right? We're going to get better innovation, and we're going to get more startups, and we're going to get more technology, and we're going to get people engaged.
Great. All right, Ben, and then Natalie, and then I'll close us out.
Yeah, really quick. Well, I like the idea of bringing in buckyballs here to the equation, but here's what I say we need. Public-private academic partnerships that can scale innovations with end users in mind when we start our studies. That's the best way. And the final thing is a carbon price would bring money, possibly if done the right way, to the Amazon and our suffering communities if it's done correctly.
Natalie?
Well, I'm sorry, I'm going to be a professor, and I'm going to say, the youth and the energy and the ambition of the youth, I'm hoping will really help us move forward on this. And that's one of the reasons I love to teach at Cornell.
Thanks to you all for what I thought was a fascinating discussion. Thanks to the audience for this panel on new opportunities for innovations in energy and climate technology. I think you can see that we're optimistic and with good reasons, given the capacity at Cornell and the commitment illustrated around the table today. Thank you.